So we want to look at this paper today. Not all tokens are what you need. Very interesting paper. If you look at this paper, the essence, the bottom line of the paper is that when you are doing pre-training of your large language models, you generally do the pre-training on some data which are transformed to tokens. Now, so in this paper, they found out that you don't need all the tokens for you to be able to have a very good performance on your p-trained model. All right, so that's the simple concept in that. So they perform experiment and they did confirm that when they train a model which they call RHO-1 on tokens, certain tokens out of all the tokens, in other words, they excluded some tokens in their pre-training, they even achieved a better performance both in terms of speed and in terms of accuracy. Okay, so that's what they mentioned. They basically use two data sets here to test that performance, and it's consistent across board. So let's go to the details and see what it's about. So they told us here that whenever you need to pre-train a large language model, you do so by predicting the next token, and it is that loss that you propagate back in what you call a causal language modeling to be able to pre-train your models. So now if you check here some of their results, they pre-train a 1 billion and a 7 billion parameters language models, and they discover that shown in this figure 1, the row 1b that they discovered that the accuracy is higher compared to the same model which they call baseline that does not use the selective modeling, like they call it. In other words, the models in blue use all the tokens, but the model in pink use some of the tokens, not all the tokens. And they found out that the accuracy is better, and they also discovered it achieved what the same performance on the baseline faster, 10 times faster here 5 times faster. But when it's allowed to train, when the training continues on using the same number of tokens, they found that it's 16.4% better. Right. So let's now go into a little bit more details as to what they did. So if you look in this figure 2 here, they show here that this is their baseline, and this is what they refer to as the RHO-1 architecture. So here are the tokens that you feed into your model. So you feed all the tokens into the model during pre-training. In the baseline, you do the normal propagations, okay, on all the tokens, right? But like they showed there, say extensively filter pre-training contains token level noise, okay, that is, they consider all these x2, x4, x5 tokens as noise. All right, so this is training on all the models. But in the right one, which they call the selective language modeling, they discarded some of the losses of these tokens, So what they did is that in the forward propagation, they sent all the tokens into the model, but in the backward propagation, they excluded the loss of some of these tokens. Yeah. So that is what they mean by selectively applied loss on those useful and clean tokens. Okay, so let's now see a little bit more details as to how they were able to get the tokens to select. All right, so they categorize the tokens into four categories. So they said some tokens show some H, that is from I to I, some from low to high, some from high to low, and some from low to low. And that's what they are showing in this figure 3, this A part. Okay, so they show some low, this green is low to low, and this like purple is high to high. All right, so now the question is, how do they decide which one is high, which one is low, which one is low to low, which one is high to high? So they mentioned it in the paper as well. So if you read this section, they talk about if the loss is increasing, okay, that is persistent high loss, that is high to high. If it's increasing loss, that is low to high. If the loss is decreasing, that is high to low. And if the loss is consistently low, that is low to low. Okay, now the question then is, how do they determine what is high and what is low? Okay, so that's another thing there. So let's look at how they did that. So if we go into the details of the model, they showed us how they determine what is low and what is high, and they calculate what they call the excess loss for every token. Okay, and is the excess loss. So if we read here, is the excess loss. So to calculate which is high to high, which is low to low, they first of all trained what you refer to as a reference model. So we train a reference model, okay, and that is using standard cross entropy. So that resulting reference model is what they use to assess the token loss. Okay, so and they computed the reference loss of each token, okay, based on the probability that the reference model assigned to that token, and this is the calculation. So this LRM is the reference loss for a token. So, and they take the log probability that the reference model assigns to that token, given that it has seen all the previous tokens. All right, okay, so and they also did some other tweak, like the number of percentage of the token, they call it selection ratio, so token selection ratio, call that K. And yeah, and they also defined what they call the IK, which is the indicator. Okay, so they define the indicator based on the top K by the selective model on each token. All right, okay, so I think that's pretty much about the model, what they did. The others are just the result and the performance of their selective model that selects some tokens. So I want us to quickly go to the appendix, and we'll see some more details in the appendix there. Okay, so in the appendix, I want us to look at how they actually selected the tokens. Okay, so let's go to that. So here they explain that several examples of tokens were selected by the SLM method. Okay, and so let's look at an example here. Okay, so here is an example. So examples of 4 categories. uh, for example, so sample test containing 4 categories. Okay, so here they show that the blue ones are the tokens that represent from high to low. The green indicate from low to low. Okay, yellow indicates categories of high to high, and red indicates low to high. So uh, they also showed a calculation, let me see, maybe together, of how they determine the range. So they show the range. I think they use zero point 0.2. Okay, yeah, this is where they show the range. So here, of how they determine high, loss, and low. So these are the loss on the 4 categories. Okay, so and here they showed the calculation of what they refer to as high and low. So they said here that we categorize tokens with, when they calculated the delta L, which is from here, which is the loss from N to start, and okay, they said if it is less than negative 0.2, they categorize that as high to low, that is the loss is decreasing, and if it is greater than 0.2, which is positive, they categorize the loss as loss to high, that is the loss is increasing. So the remaining two, if it's in between negative 0.2 and 0.2, and this is less than the mean, they categorize the token as low is remaining low, and if the ln is greater than ln, they categorize this as high, that loss remain constant. So that's how they did the categorization of which is high to high, low to low, and all of that. Very interesting paper. You can look into more of the calculation of how they did the different losses. Okay, yeah. All right, so I'll just stop there. On that, they trained 1 billion and 7 billion parameters, and they consistently found out that the the selective model works very fine. One last important thing which I've explained in past is showed in this figure 4, which they trained first the reference model. Okay, so what they want to do is to concentrate on the clean tokens during pre-training. They train a reference model, which in this case they use model less than 7 billion. I think they use the Tiny Llama and Mistral. So they train that as a reference model. So they use the reference model to calculate the token's perplexity, which I showed earlier, the delta L. Okay, and so they now have a different pre-training corpus after determining which of the tokens are not necessary. So the filtered tokens are what they now use to train the LLM, focusing on the I token. Remember, they did not remove the tokens. All they did was that during the back propagation, those tokens that have been excluded and their loss was not propagated to update the weights of this selective model. Yeah. So they trained the language model on tokens that have higher scores. That's it. All right, so that's it. Thank you very much for listening, and see you in another one.